So it's the density of the fluid. Okay. So of course you know if the in a similar situation, the resistance in the water will be much larger than the resistance in the air because water is much more dense than air. Okay. And another thing is the cross-sectional area of for the object. Okay, so and um, okay, the third factor to affect the frictional force is the drag coefficient. The drag coefficient actually depends on the shape of the object. Okay. And the last one is the velocity. Faster moving objects will have a larger air resistance. Okay. So here, let's look at first the effect of the cross-sectional area to the air resistance. Okay, so that's in fact related to the discussion of the free fall. We know that every object in the free falling motion, they should drop with the same rate. Okay, but of course you notice that a stone is much faster than the feather. Just like here, if I drop the ball and the piece of paper, of course the ball will be much faster than the paper, right? Okay. And this is actually the reason why Aristotle concluded that heavier objects drop faster. But in fact, he didn't realize that this is actually the effect of air resistance. Okay, we can show this by another set of experiments. I have two identical papers. If I squeeze this into the paper ball, and you can see. Okay, it will drop very fast, and you can even check these two drops almost with the same rate. Okay. Right? So it's not the mass of the object. Okay, contrary to the theory of Aristotle. In fact, every object drops with almost the same weight if you ignore or neglect the air resistance. But of course, for this piece of paper, because it has a very large cross-sectional area, okay, so it will feel a very large air resistance. On the other hand, it's very light, so even a small air resistance can change the acceleration totally. So that's the effect of the cross-sectional area. And now, what still, okay, need to introduce a drag coefficient, because if you look at this stuff, okay, if they drop to, let's say, this direction, so the air resistance is to the right, all of them have the same cross-sectional area, okay, but they feel different air resistance. So not only the cross-sectional area, the shape of the object also matters. If you look at this one is the most bad, so that's why when I drop the piece of paper in this way, the air resistance is very large. You can see compare this. This one is, if you 1.1, if you have some spherical shape, it's better, 0.45. And this one, if you make the sharp side to in the direction of the motion, is 0.34. Okay, but the best is this well-known shape. Okay, what we call it, drop-like. Okay, drop shape, 0.05. Okay, so if you drop something and it's in this shape, it will take the least air resistance. In fact, drop it's funny that the raindrop initially it is spherical shape due to the station surface. It will have symmetrical shape. It only becomes to this kind of shape during the drop. Okay, so because water drop can change its shape, so it will take the advantage of this kind of shape. So during the motion, it becomes to this. So it will feel less air resistance. Okay. So drag coefficient of this shape stuff, of course, are very important in the design of the aircraft. Okay. You can see the wings of the airplane. If you look at the from the side view, it's kind of like this. So it's kind of water drop shape. Okay. In fact, later when you study the fluid dynamics, the water drop shape, there is another important advantage of this. It can stable the motion. Okay, because it will make the flow like this way, so it will reduce the possibility of the turbulence. Okay. So that's the drag coefficient. The last thing, of course, depends on the velocity. This is quite different with other frictional force. Static friction, kinetic friction, and rolling friction, they are not depending on the velocity. So moving faster or slower, you feel the same amount of frictional force. But air resistance, okay, it highly depends on the speed of the velocity. So at a very low speed, the air resistance is very small. And high speed, it becomes very large. In fact, the air resistance proportional to the square of the velocity. Okay, so the dependence is very sharp. So that's why when we are talking about the resistance for some slow motion, even the vehicles in the highway, okay, you're focusing their speed is quite fast, but in fact it's slow. For vehicles in highway, the most important resistance is still the resistance from the ground, not the resistance from the air. But for airplane, okay, of course there is no resistance from ground. But anyway, for airplane, the air resistance is very large because airplane flying very fast. Okay.